I'm Seth with Classic Heating and Air, and I wanted to quickly go over why all of the reliable conventional thermostats and HVAC controls have a 5-minute compressor delay in them. When you look at any HVAC system, you will have, let me get another marker. You will have the outdoor unit, the condensing unit. You'll have an evaporator coil in the attic. And then indoors you also have a furnace. You're going to have the thermostat over here, which I'll mark with a T. These units, both the condenser and the evaporator coil, are moving a refrigerant between the two, and they're going to go through an orifice or an expansion valve of some type to meter the refrigerant flow. Whenever the condensing unit's running, you will have high pressure going to the coil, low pressure returning back to the condensing unit to be compressed again. When the thermostat's energizing this cycle and getting it running, you then have, when the unit turns off, immediately you will have this metering device will divide the system essentially into high pressure and low pressure. High efficiency units that we have today, 14 SEER and above, are going to have a lower horsepower in them than older units, such as 12 SEER, 10 SEER units, even 13 SEER units. They made them more efficient by lowering the horsepower of the compressor in the condenser. What that does is it makes it where a lower horsepower motor is also not as strong as a higher horsepower motor. It does conserve electricity, but it does weaken the amount of strength that that compressor has. So that we then have an obstacle to overcome. The compressor essentially is stuck with high pressure on the head side and low pressure on the other side. It's going to take a large amount of force to get this moving again to overcome this high pressure. The 5-minute delay is there so that the pressure can equalize through the expansion valve. The high pressure can move to low pressure and equalize to where then you're just going to have basically a static pressure or a pressure that's equal on both sides. That 5-minute delay in the control allows that to equalize. If you don't have that 5-minute delay to allow just the refrigerant to equalize across the valve, you will then have a compressor trying to start with high pressure still sitting on the compressor. Today's efficient units cannot do that with the lower horsepower ratings of the compressors that do in fact conserve electricity. They just simply don't have the strength to overcome that high pressure. What will happen then, there's an internal overload in the compressor that's built in as a fail-safe so you don't blow compressor windings, things of that nature, and it will kick into internal overload immediately if it tries to pump this high pressure directly off the head of the compressor. You simply can't do it. The equipment's not strong enough. The 5-minute delay is crucial because it allows it to equalize. We see a lot of problems with some of the newfangled thermostats that have all sorts of interactive features in them, connectability. Those are great things, but we only really endorse and recommend controls, thermostats, etc., that are designed by HVAC manufacturers, HVAC companies that have even adjustable delays in them or cycle delays in them. These can range from 2 to 5 minutes on most thermostats that the industry uses, and we can go in and adjust them. If a unit will get by with 4 minutes, so be it. But 5-minute is really where the rubber meets the road. 5-minute delay will ensure that all systems of any type, brand, manufacturer can equalize, which will allow a certain and sure startup every time, no internal overloads, no problems.